Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, we're going to look at doing double integration in a fairly simple region. We're going to integrate first with respect to y, then with respect to x. And this is taken from a textbook by Burden and Fairs, Numerical Analysis. It's a fairly straightforward application of what they do. So I named this double Simpson. It's going to evaluate a function where the y variable is from c to d, which those can be functions, the x variable from a to b, and n is the number of intervals for my x, and m is the number of intervals for my y. Because I'm doing it with Simpson's rule, both of these values must be even. They don't need to be the same, but they need to be even. And so the first thing we do is a check to make sure that I really do have something even entered for the number of intervals. And then I evaluate my h, my delta x. So h is b minus a over n. And then we initialize. So I've got the terms that are going to be multiplied by 1, the terms that will be multiplied by 2, and the terms that will be multiplied by 4. And I'm going to set all of those initially equal to 0. And then I'm going to count from 0 to n. I'm going to let x be a plus I times h, so my counter. So that's going to reset where I'm starting my x values. And then hx is going to be the width of the intervals in the y direction. So d of x minus c of x over m. K1 is my initialization for in the y direction. I have k2 and k3 are initialized as 0. And then I'm going to go through and loop for my y counter from 1 to m minus 1. And so I'm going to add up my f of x delta x, essentially, for that. Adding my terms, checking and seeing whether I'm on the one that gets multiplied by 4 and the one that gets multiplied by 2. Adding up the various pieces once I've got them all sorted out, and multiplying by the appropriate multiplier 1, 2, or 4. Times my delta x, or I guess that's delta y, over 3. And then going through and hopping across, doing the same thing in the x direction with a final answer here. So really it's just doing the Simpson's rule within the Simpson's rule. Now to test this and see whether or not we've got it right, we're going to evaluate this integral, which the nice thing about this one is it should come up to be a value of 1. And so I'm going to have my function is x squared plus y cubed. My limits of integration are x and 2x, and 0 and 1. So if we set these up, I want to define these. So c, I need to be a function, however you wish to define that. But d is also a function, at, and this is 2 times x. And then a is my x, it's a constant value of integration. B is the upper limit for x. I don't know, what do you want to choose? I'll choose 10, just as long as it's something even. That's the number of intervals in the x and y direction. And then my function that I'm going to integrate is at xy, so I've got two variables. It's x each term squared plus y each term cubed. And now I want to run my function. So it was named double Simpson. F, C, D, A, B, N, and M. I've got lots of variables here. And we get 1.001. I was looking for a value of 1 for an approximation. I think that's pretty good. So this is a way of doing double integration. Now there's some other ways you can do that are perhaps better and may work better with data, but just want to get you kind of used to the idea that you can use these same simple formulas to do double or triple integrals if you need. This concludes this video. Thank you very much for your time.